We get many questions from young photonics companies trying to scale up production to serve new markets and increase their turnover. And that's where Optica can help, because we have access to leading CEOs and CTOs in over 600 photonic businesses who have the wealth of experience and are willing to share their advice with others. In this series, we explore the business strategies being developed by industry leaders. I'm joined at the questioner's table by Michael Hochberg, a well-known physicist and entrepreneur in the field of silicon photonics and large-scale photonic integration. We recently sat down with Dr. Beck Mason, who is currently Executive VP Telecommunications at Coherent. We know today's Coherent as a global manufacturer of photonic components and laser systems. The company is headquartered in Saxonburg, Pennsylvania. In 2023, II-VI acquired Coherent and then changed its name to Coherent, and that had a major impact on the entire optics and photonics industry. Beck Mason joined them from a previous appointment at Lumentum, where he helped to guide their technology strategy. And prior to that, he had leadership positions at Oclaro, Jiris Uniface, Collinear, Finisar, Agere Systems, and Lucent Technologies Bell Labs. So we were curious to find out what kickstarted his interest in photonics.
Let me start with a simple question. How did you find your way into photonics?
It's very interesting. I actually started my career in aerospace engineering, if you believe it. And way back, and this is more than 25 years ago, we were working on putting fiber sensors into composite wings of aircraft for military fighter jets. And one of the big challenges in the fiber sensors was developing tunable lasers to interrogate them. And so I got the interest in tunable lasers from that. And that led me to choose to go to University of California, Santa Barbara, to study with Larry Coldren, who is a true giant in the industry, and to work on tunable lasers with him. And so that's what started my entry into photonics and into the whole communications industry.
And this was for strain sensing?
Back in the day, it was for strain sensing. That's correct.
Neat. What are the things that have stood out in terms of culture and in terms of practice and in terms of, what makes the teams work at the places where you've been and where you've been impressed?
In my experience, there's a couple ingredients to success. One is a clear vision and a direction on where you want to go with the team or the product or the technology of the company. And then the second thing is building a strong team of individuals, right? It takes a big group of people to tackle the enormous technological challenges that we face in this industry. And it's the strength of those teams with their diverse skill sets and capabilities that really ultimately is the best indicator of getting to success.
When you think about team dynamics, how do you think about maintaining and sort of the care and feeding of like really high performance teams? I mean, if that's the essential ingredient, how do you think about creating differentiated advantage there?
Yeah, this is a very important question. And in my experience, strong teams come from strong culture, right? And you have to build a strong culture in the organization. And today, being at Coherent, it's exciting because that's a company that I think has extremely strong culture. And ultimately, that does come from the top. It comes from the tone and tenor of the CEO. You probably know our CEO, Chuck Matera. He's a giant in the industry, but he drives a standard of care of employees and people that builds teamwork down throughout the organization, right? And teamwork ultimately comes from trust, and trust comes from knowing that the people on the team have your back and are committed to the same success and mutual goals of you and the organization.
But now, Beck, that you mentioned about company culture, I mean, we are talking about Coherent, which rebranded from II-VI and did acquisitions, and it was from the Finisar time. How do you keep a company culture when you are rebuilding, growing, and changing?
It's extremely challenging. And as you said, Coherent is the accumulation of many very successful companies that have been added together to form the whole. One key ingredient, I have to tell you, is travel, right? So you have to go meet the people, spend time with them, get to know them personally and on a professional basis. And Communication is also critical. So keeping the open lines of communication across the business so people know, what their role is, what their critical contribution is to the success of the company, and where the company is going as a whole.
One of the advantages I feel like startups have is that everyone gets to meet the leadership cadre frequently. And so, there's a lot of personal contact. And so that helps to build trust. The one of the things that I've seen is that the big companies have actually weathered the remote work thing in many ways better than the startups have, because if you have the trust built up and you have the culture that's stable, it's in some ways it's easier than building it from scratch, because if you have the cultural capital and then you go remote, like we experienced this at Elenian, you go remote, you already know everyone. It's not so bad. Building from scratch as a remote organization, it's just brutal.
It's very tough. I think a key to that is, again, what I said about teams, right? Teams take time to build. If you look at a highly performing R&D organization, that can take decades to really bring together and formulate. And startups do this in a very short period of time. And they do it with that intimacy of the team and the people, usually in one location, and that's a great advantage. And so you're right, the remote work has made that very hard. In larger companies, we benefit from the fact that even though we have many sites and many groups, those teams have worked together and know each other and have worked together for an extended period of time, and that team dynamic is already formed. And so you just have to protect that as best you can. And even that is challenging. So I think we're all very happy at Coherent that we're back from the remote working and back into the office and back into the labs and back to collaborating together in person more.
What do you see as some of the other big challenges as Coherent these days?
Well, we are a very complicated business. We have many, many different product lines, markets, technology bases, and trying to manage that diversity and complexity is difficult. The business model around building very high performance lasers for cutting, welding, making flat panel displays is very different from that to produce millions of pluggable datacom transceivers a year. And trying to have business systems and processes that effectively work across those is a big challenge for us.
It sounds like an incredibly difficult thing to manage.
It is, and I think the executive team does a fantastically good job of it at Coherent, but it is certainly a challenge for us.
One of the things I always tell young entrepreneurs is that, the first thing you have to figure out is how to manage yourself. And then, you get to managing people who do something you understand, and then you sort of progress up the ladder. Your organization grows, whatever it is. Get to the point where you're managing people where they're doing things that you just don't know very much about, and that level of leadership is I'm sure you've thought deeply about that transition into leading teams that do things where you couldn't possibly have expertise in everything that the people are doing who are reporting to you. Do you have any thoughts about the challenges of that?
There's two challenges I see. Sometimes in technology companies, we have very talented engineers, and those engineers grow in responsibility because they have a vision and a strategy and they know how to drive things. But we can neglect to teach them management skills as they climb that ladder. And that's a really important function to invest in and to develop both those skills as well as their technical and strategic skills. But to me, having an understanding of what your teams are doing, at least at a base level or superficial level, is really important to understanding the challenges they're going through. So I'm a deep technology guy. I started device physics. I love the technology. That's why I'm in this business in general. But the most exciting thing for me is when people that work for me teach me stuff I didn't understand, or show me stuff that they're doing that I couldn't dream of accomplishing. And that's actually really exciting. And if you can embrace that feeling and understand enough of what they're doing to be able to support them and give them the tools they need to be successful, that's the biggest win in this business.
It's always a great pleasure when you have people on your team where they walk through the door with some impossibly difficult problem, and then they also have the solution in their other hand, right? Or at least the beginnings of a solution. The So is that the thing that really excites you most about when you see new projects? Like when you see a new project or new activity or a new company that you're looking at, like what's the thing that really gets your attention?
Uh, I mean, I think there's two things that I really get excited about. One is a new product or technology having a big impact on the customer. And I know that sounds a little bit like a platitude, but it is so rewarding for engineers and scientists to see their product out there being used and deployed in thousands of applications and having a big impact on overall network capability or society in its application. So that is always one of the biggest buzzes. But the other thing that excites me is seeing technology do things that I never imagined we'd get to. When I started in this industry, OC48 or 2.5 gigabits per second was the pinnacle of photonic communication technology. And I thought one day maybe we'll get to 40 gigabit per second transmission before I retire. And now we're well past 800 on our way to 1.6 terabits on a single wavelength, and there's no signs of stopping. So I'm constantly amazed and excited by the ability of the industry as a whole to continuously solve problems that we thought were unsolvable before.
Yeah, and it's an amazing dynamic because even within the industry, and you're in a perch where you see a lot of what's going on.
Mm-hmm.
You you look at a problem that's maybe not right within the domain of what your own teams are doing. And it might look like an impossible problem, but somewhere in a dark corner somewhere, there's someone solving the problem. And you don't necessarily see it until it pops up. I mean, this is the reason that people were always, for a long time, Moore's law was 2 generations from being dead
Yep.
for 10 generations.
Right.
And it wasn't because of anything fundamental. It was that unless you were really in the thick of it, you didn't see where the solutions were coming from outside of your own specific domain.
Yeah. So we got up against the limits of what you could do with on-off key transmission, and we developed coherent solutions, right? And when we get up against the next level of physics, that's when we see the breakthroughs and the exciting things happen.
And at the end of the day, you have the best of knowledge from the German lasers, the Excimer lasers from Göttingen,
Yep.
and you had the volume production and the micro optical elements in many huge applications. And that's a challenge, but also a beautiful position to be in.
It is a very exciting opportunity. I can tell you that my team, especially in the process side, have started doing a lot more work with our commercial lasers partners, because you can do amazing things in process engineering on materials with some of the laser technology that we produce on that side of the business. And it is really exciting to see those teams coming together to solve new and unique problems that couldn't be solved before. So yeah, I agree. That's a great advantage.
Manufacturing problems.
Yeah.
That's the next step. Now we are going to high resolution laser based manufacturing. We are going to bringing our devices not only to datacom telecom but also to consumer applications, and that's where you bring now the strength of the new Coherent, the strength of being a manufacturing laser based manufacturing company and a device company.
Let's say you have a startup company that's walking through the door, right? Startup team. They might be a collaborator. They might be, a potential vendor. They might be pitching you guys on becoming a customer for something. What do you look for in the startup team? What are the red flags? What are the green flags? What are the things where you see it and it makes your hair stand on end? Like, what are the things that make you want to work with a startup that walks through the door?
That's a really good question. I think one thing I would like to say, I love meeting with startups. I think they are the lifeblood of new ideas in our industry, and they're an essential part of moving us forward. I meet with a ton of bright young people with amazing ideas every day, and it's hard because sometimes you can engage and you can move forward with them, and sometimes you can't. But what I like to see is a clear vision of the problem they're solving and how they're going to get to a path to the end. And there's a delicate balance too. You can see people that are really reaching far out. And in some cases, you can say, well, that's really exciting, but I can see that that's got another 10 years to maturity, and good luck, and I'll be happy to track your progress. And others that are sort of more near in. And it's that delicate balance of being disruptive, but not too far out of the realm of practicality that I try to find when we find those gems that can really move things forward, right?
One of the things that I often hear from startup teams is that they're afraid to talk to big companies because they look at the big company and they say, these guys have infinite resources. They could look at our deck and decide to replicate what we're doing. And one of the pieces of advice I often give people is that big companies, they don't really see you as competitors for the most part. And there's different cultures in different places. They see you guys as a pipeline of organizations that they can buy, they can bring in.
Yeah.
They see you as an R&D innovation pipeline. Does that resonate?
Yeah, that's exactly right. And I would say we see it sort of in three ways. One is potential future partners in their company, potential future suppliers, or even potential future customers in some case. And I think you're very right. When we see startups come, the last thing in our mind is how can we go do exactly what they're doing? It's really either, wow, we should buy these guys. They should be part of our company. We should partner with these guys, or we should see how we can help guide them to get their technology to a level where it is going to be interesting and unique. Because I've seen fantastic teams with amazing creativity and capability, and sometimes they're a little misdirected on what the right need is in the market, and that's a little bit of guidance that we can provide. So, most large companies really want to foster and engage with the startups and see them as a vehicle to further their own business in a positive way.
Yeah, Michael, this goes both ways. I have seen also startups that complain that it's very difficult for them to understand what are the challenges of the big company. And sometimes they shoot in the air. I mean, your past is very clear on that. We were working on many different silicon photonics startups and we were trying to solve challenges. And later, when you were talking to the big companies, the truth was that those companies didn't consider that a real challenge. Is there any kind of work that Coherent does or could do to guide better the startups to solve real issues?
I think the number one thing we can do is engage with them and share with them what our needs are and what we see of the market. And our vision is not perfect. Obviously, we do have a broader set of capabilities and a broad set of people that look at the market and look at our challenges. And to the extent we can share that and tell them what we need, that's the best feedback we can give them.
Oftentimes, the best opportunities for startups are non-conflicting with big companies because if you're a Coherent, right, things that don't have a lot of zeros behind them, even if they're good markets, you often have to leave on the table because it's a distraction in one way or the other, unless it's extremely strategic. And so, for startups, the things that are one or two orders of magnitude down in terms of size, but where they can generate differentiation, those are often great markets for a startup to get in as a wedge into the market, right? So oftentimes it's something where it's a great opportunity, but it doesn't make sense for a big company. It actually makes sense for someone smaller.
Yeah, that's very true. I mean, I think of those more as like bootstrap startups they're trying to build a business around a capability and an approach, and that's one class, and that's very interesting. But the ones that I think are more interesting are the ones who have very disruptive ideas, very clear vision, and can help us leap ahead. Right?
Yeah.
Sometimes we are very occupied with solving the problems of today.
Yeah.
And what the startups can help do is solve the problems of tomorrow ahead of us and give us a way to leap forward with them. And that's the stuff that I think is the most exciting for us as a company and actually for the industry.
It's so important to engage with the big companies so that, you know, you can buy the things that you can buy and and avoid building things that compete with something you can buy off the shelf.
Right.
And so, you know, engaging in those conversations to say, oh, well, what's on your roadmap? What can I integrate rather than trying to build it myself is just it's a big differentiator.
Venture capital has an important role to play in that. I've found that a lot of venture capitalists are very good at helping startups identify that piece of unique value that they are bringing, right? So they're not replicating value that they can get somewhere else in the market, but they're bringing something that's unique and differentiated. And focusing that vision is a really important piece. And that's an important role that VCs can provide as they provide funding, because they can help to focus that. And they can also help to identify where startups have gaps in their teams or their capabilities that they're going to need to fill, because they've seen it before. They say, look, here's how you got to put your team together to go be successful.
When you talk to founders, what are the couple of top pieces of advice that you give them?
Build a network, right?
Yeah.
Build a broad network of people that can help you with advice, with feedback, with engagement, and foster that network. So that's an important piece. 2, don't be stuck in one vision all the time. Be open to change, be open to redirection. I've seen phenomenal startups that started out down a single path and then pivoted to something midway and drove that to great success, right? And the last piece is the success comes with hard work, right? And I think they know it, but there's no substitute for that hard work and that engagement from their team and their people themselves.
The overall message with the startups is that the startups move fast. So even though large companies have big R&D teams that could perhaps do the same thing, working with a large company on an R&D team doesn't necessarily have to be at that same kind of level of pace. So for companies like Coherent, having those startups pushing the boundaries and moving the way that they only move, and we can see most of the exhibitions how a startup from one year to another has an improvement that large companies would take several
Yes.
years.
Yeah, I really agree.
Shifting gears a little bit, tell me about a big impactful mistake that you've made in your own life.
Oh, so I don't want to be too specific, but I will say that there was a time when I had an opportunity to invest and pursue a product development around a technology that had an interest from a customer. And when we reviewed the approach in our engineering team, we really thought it was ridiculously bad. We thought it was a terrible technology and a terrible approach. And we were right technically, but that's only a piece of the analysis.
Yeah.
If you have a customer and they have a need and they're willing to pay for it, in the end, that's our job as a company to go serve. And that application, even though it was based on what I consider to be a very poor technical approach, ended up being commercially very successful because there was somebody who was willing to pay a lot of money for it and had a lot of demand. And so the lesson I learned from that is, don't be myopically blinded by your intellectual egotism around what you think is the best or the worst technology, but be open to what the market need is and what the customers are saying they actually want. And so that's a very important lesson, no matter what you're doing, right? Is listen and hear the voice of the customer properly.
One of the things I'm personally very excited about, have been for a long time, is the integrated optics world, specifically silicon photonics, but more broadly. What are the things that you think are needed from the industry? What needs to change? What needs to show up for the integrated optics field to continue to grow?
There's a couple pieces to this in my mind, and there's probably 1,000 other things that are needed, but here's a couple things for me. I think silicon photonics is a phenomenally capable technology, and it's having a huge impact on the industry, and it's continuing to find many interesting and diverse ways to be applied. And I even saw some exciting new technology around the design from X at the Optica forum. But I think the fab technology is still got to mature.
Yeah.
The process capability, the tool sets, the PDKs, and the repeatability is still not where it needs to be to really enable silicon photonics in the way that CMOS technology enables digital device IC design. So there's more maturation in that silicon photonics foundry industry needed. And that's a real challenge. Second thing is, there's multiple material systems that we need as we go forward. So silicon photonics is an important one. Thin film lithium niobate may be a very important one. Indium phosphide is a very important one. Gallium arsenide is a very important one. And the fab technology in 3.5 has got to evolve and get to the next level. So, and this is a shameless plug, but we are investing heavily in getting indium phosphide to 6-inch wafer size. And we just announced at the show. But as an industry in general, that's an important transition for two reasons. One is scaling up the wafer size drives tremendously improved economics for indium phosphide. And indium phosphide is a very valuable technology in long wavelength communications because of the wavelength it produces, because of the speed of the modulators, and the capability of the technology overall. So scaling that to larger wafer sizes, better economics, scaling it to next generation fab technology is a critical piece to getting, our 3-5 wafer fabs out of sort of the early cottage industry phase into real industrialization and real scalability, right? So that's another piece I think that has to happen.
Coming back to the point of silicon photonics, when Michael and I started working on silicon photonics, we were mostly seeing an ecosystem of small companies. And now, if you see who is doing silicon photonics, we see Global Foundries, we see TSMC, and we see who their customers are. And their customers are companies demanding high volume applications, such as, of course, Coherent. Right. So things are going in the right direction. When you say that we are not industrially ready, what kind of tweaks can we still make? What is your preferred future for the silicon photonics community to be ready?
I think the reality is that even though silicon photonics has come a long way and volume applications are growing, the total wafer count in silicon photonics is still a tiny fraction of what's run for, say, CMOS or SiGe applications. And maturity has come a long way, but I just think there is more maturity in process capability and process control needed to get that to the next level of effectiveness in the market, right? And we still see a lot of variability on silicon photonic components that obviously we're trying to address and eliminate. And we still see that there's more capability that's needed than the devices can produce today.
One of the ways that you can address the variability in a lot of cases is with sort of on-chip active control systems.
Mhm.
And I've seen some examples of this over the years. And I think one of the interesting things about silicon that may be unusual is that there are opportunities to solve process control problems by throwing active control complexity at the system. Now that always comes at a cost of power, and it comes at a cost of design complexity. And it's sort of similar to what's happened in the RFIC world, where you throw design complexity at things to solve problems. But the number of design teams that know how to do that is so small, right? There's very few places that have that whole skill set, from optics to electronics to RFICs to packaging, where they can really pull it all together.
Right.
I think one of the limiting factors is just the availability of people who can think across domains, and of really first-rate design tools that operate across those different domains.
Yeah, I tend to agree. I mean, I think the whole aspect of control and engineering around process capability is a really important dynamic. I mean, it's been something that obviously people have been doing in indium phosphide and other technologies for years. You pointed out in RFICs, it's an important factor, and I think it's an important tool in silicon photonics to increase yield and increase performance as we put more and more demands on these chips and this capability of the process. So yeah, it's very insightful. The other point you made, I think, is a really important one. Having people that understand multiple disciplines that act as architects and integrators is a critical function in everything we do, right? And these people are not common, but we can help to grow and build them by integrating new young engineers into our companies and allowing them to move into different disciplines and experience different areas of development. I started out in mechanical engineering. I went to aerospace engineering and finally to EE and device development in my PhD. That diversity of experience helped me a lot in my career. I wouldn't say that I'm a credible mechanical engineer at all, but just that background helps me understand a little bit more the challenges of people that have to integrate all these different technologies.
Yeah,
When you talk about moving to 6-inch in indium phosphide, that is a big increase in volume. So what are new applications that you think are going to be ramping up to demand that increased volume?
AI. I mean, AI. I mean, it's incredible the demand ramp we're seeing for EMLs and for high-speed photodiodes, for datacom transceivers for 800 gig and 1.6 terabyte. It's on a very steep ramp, right? And as we're developing new chips, obviously we're developing solutions with higher levels of photonic integration in indium phosphide, and that benefits from larger chip sizes. But even at the sort of modest volumes that are run globally in indium phosphide, the benefit of going to 6 inches really the fact that it moves you to a process capability that's very low touch, right? Fully automated, and while that gives you far better opportunities to scale volume, even at lower volumes, it substantially drops the cost. And so we're seeing, I don't want to get too much into economics, but there's pretty amazing cost reduction by scaling up wafer size. And it's something the silicon guys have known for decades, right? And that's why they've driven all the way up to 300 millimeter wafers.
I imagine all of the different pieces of the ecosystem, moving them all to a new wafer size as a single company. I mean, usually in the semiconductor, in the silicon industry, this happens as a part of a coordinated roadmap across the whole industry. It sounds like you guys are blazing a new trail here.
Well, I mean, we are benefiting from a strong ecosystem. First of all, we've been doing 6-inch gallium arsenide wafers for a long time, and we do those in very, very high volume today for VCSEL applications. Secondly, a number of the tools from the silicon industry we can leverage, from the steppers to the spin and bake tracks, the etcher capability, all the wafer handling capability. So there's an enormous ecosystem capability out there. And then we have core partners, like partners that help us developing the indium phosphide substrates, partners that are helping us develop the back grinding and wafer bonding technology to thin these effectively. So it is a real ecosystem necessary, and I think other indium phosphide foundries are gonna follow the path. Right, we're maybe blazing the trail, but I expect the industry will come behind us pretty quickly.
Do you see a path to 8-inch indium phosphide?
Eventually, of course, right?
Yeah.
I mean, the biggest thing I learned in my career is never say never, right? Every time you say something can't be done, someone goes and does it and makes you look like a fool. So I'm sure, right? And the challenges we found in going to 6-inch were really a lot around the substrate quality, right? Can you pull a boule at that size? Can you refine it to get the defect densities low enough? And can you fabricate it? Once you get past that, most of the other equipment in the semiconductor wafer fab actually works better as you get larger. Uniformities get better. Your epi reactors to work better. I mean, it's there's a lot of goodness that comes through that transition, which is great to see.
So as you've looked around the industry the last few years, I mean, what's really surprised you?
I guess consolidation has moved faster than I thought. The industry has really consolidated a lot. I think in general the technology has moved just much faster. If I could go back 10 years, I would never have imagined that we've made the progress that we've made today in so many areas, right? I never would have believed that VCSELs would get to 200 gig per wavelength.
Crazy.
Never. I mean, I was a skeptic at 50 gig, right?
I was too, by the way.
I'm trying to think about all the things I've been wrong about. It's astounding, right? But I just never would have imagined we'd go as far or as fast as we have. I think every year gets more exciting. I'm really excited about AI. I think AI is a foundational change, not just in the technology world, but in society in general as it comes online. I'm nervous about it, but I'm also excited about the capability we're driving there. And I think that's kind of like the next wave. We had if you think back to 99, 2000 timeframe when the internet was just exploding, right? That was a huge wave and it transformed society. And I remember hearing a keynote at OFC back there and I can't remember who it was, but he said the internet is like the discovery of fire. And he was absolutely right. And I think you're going to find the AI and the explosion in that technology, even though that's been decades coming, is going to be another transformation, is exactly as significant in what's happening in society and in technology, because it's going to help us move technology even faster. If you think about the internet as it exploded, how much it disrupted society, how much it disrupted legacy businesses, AI is going to do the same. And it's going to do it in even a broader segment of society, right? You can't even think of living now without using the internet. You can't make a plane reservation. You can't rent a car. You can't drive anywhere. You don't do anything where you're not almost always actively using the internet. So it's pervaded every aspect of society and changed how we do everything. And I think AI is going to have that same level of transformation. And so it makes me very nervous that that disruption, what it's going to cause.
So that's an area where we have a new thing that's disrupting the world. There's also some old things that are coming back. Geopolitics has become important again. You know, the world may be getting, it seems to be getting a lot less flat.
Mm-hmm.
How have the events of the last couple of years, in terms of nation state actions and geopolitical chaos, how has that impacted your business?
Yeah, that's been a big negative, I would say. I mean, we're managing our way through those challenges, but just in general, and not just related to business, I think the world was on decades of progress towards more openness, more collaboration, more integration, and it feels like over the last 10 plus years, we've just been going backwards, and it's accelerating. And I don't think that's good for anybody. It's not good for society. It's not good for any individual country. So now what it's forcing us to do in the company is we have to be much more careful in the diversity of our manufacturing base, diversity of where we develop products. We have a vastly increased effort to ensure we're compliant on the trade front, to make sure that we're not selling the wrong technology, the wrong person, to make sure that our customers aren't selling our technology on into the wrong space. And that takes enormous diligence and enormous focus. And in general, within some of our end markets, there's a trend towards local consumption, local production that's limiting our ability to access the markets as effectively.
Of course, there are two ways to address this: abide the rules despite of them being unfair and not good for the industry, or trying to change the rules. Is there anything that the photonic industry could do together, line up with other industries and try to change this?
Well, I think we have to lobby governments in favor of more free and open trade practices. Now, I'm not an expert in geopolitics, and I know that there are some real and valid concerns around some areas where our technology is getting that we don't want it to be, and so those are legitimate concerns, and we have to be compliant and supportive of government efforts there. I think the biggest thing that we are doing, and I think the industry can do, is to build more partnerships. The more we partner with local companies in local countries, the better we're able to satisfy their needs to drive their domestic economies and their domestic capability on technology and production, right? And that helps open up markets for us, and it helps them achieve their goals as well. So, within the extent of just the pure economic aspects of the I guess tightening of trade restrictions, I think that's the number one thing we can do to help alleviate some of those concerns. But we do have to push for as much open trade as we can get. Coherent right now is entering a phase where we have a really interesting set of technologies that are going to kind of develop over the next 10 years in a big way. On the networking side, I see us really extending our reach into more and more diverse product sets and working more towards end customer solutions, right? So not just components, but systems and higher levels of integration, leveraging capabilities that we have in digital signal processing design and CMOS, in RFICs and photonic components and packaging integration to better serve the market. I'm sure we'll be carrying forward to data rates and capabilities that I'm not properly imagining today, which is exciting. I see us continuing to expand the breadth of technologies that we're in and entering new markets. We have a trail being blazed by our lasers business that is in display, is in manufacturing, is in sensing, is in medical applications. And we're seeing great cross-fertilization between our materials business, our lasers business, and our communications business.
Like, what's the one application that would make you really happy that we will get there?
For me, I mean, I have sort of small aspirations. I'm going to be really excited to see 1.6 terabit single lambda coherent come to market. I think that's a really exciting technology challenge that we're taking on now. It's small, but for me, that's very exciting, and I think it'll be very important in the market. It's hard to just pick one thing. I do like seeing the 6-inch indium phosphide come to market. I think that's now kind of there. So I don't want to say it's fully solved, but it's a technology challenge that's more in our block and tackling zone, right?
So let me ask you one more question, then we'll wrap up. What's an unorthodox view that you've developed over the last few years? Something that you think is going to surprise and shock the rest of the industry a few years out?
If you think about really advanced technologies, I think quantum computing is going to come to the fore.
Hmm.
I think we're going to make it practical eventually, and I think that's going to be something that's going to push our capability forward in a really exciting way. I think there are huge challenges on the technology side to solve that, but I think there's a lot of really smart people gradually making process chipping away at that. So I think that's a very exciting thing that's going to come.
Cool. Well, thank you very much for your time. I know you're super busy at OFC and really appreciate your carving out the time to talk to us.
No, thanks for having me, and it was a great pleasure to talk to you.